everybody. The series of videos you're about to see here were videos I shot of me digging into my Canon Powershot A470 digital camera. The reason why I tore into it was because the shutter was stuck. It would not close, so pictures would be heavily overexposed when you went to take pictures with the camera. Now these videos that you're about to see here, I never did actually do a formal introduction to the video because this is actually I actually shot some videos of me trying to do repairs, some repairs I had found online. It involves steps of powering the camera off a certain way, powering it on a certain way, tapping the lens assembly while doing a long exposure, and just all sorts of weird stuff. And unfortunately, it didn't work out. And these videos you're about to see really were more of a continuation on that series of videos, but unfortunately I was not able to actually repair the camera, but I figured I'd still post these videos anyway, so that way you could see inside a digital camera and see that there are actually hazards inside the camera. So yeah, these videos may not be the most exciting, but I did not want to trash them. I figured I'm just going to post them anyway for those of you who would be curious to watch. Anyways, hope you guys enjoyed this for what it is. Here we go. Now, while I do not mind at all opening up video cameras like the one I'm shooting video with right now, one of my modified Kodak Z6 cameras, conventional photo cameras I do not necessarily like dealing with. And there's one big reason that you may not be aware of, and I think this would be a good opportunity to make you aware of it. Although there's no sort of indication of warning not to open the camera, conventional photo cameras that have flash built in do pose a pretty significant electrical hazard. They have a capacitor inside that can hold a charge for the flash circuitry, and this capacitor is usually rated at between 300 and 330 volts, and the capacitance is usually pretty low. It depends on the camera, but if you touch it and it's charged, it can send you across the room and onto the floor. Now, it hasn't personally happened to me, but I have had a close encounter one time with a flash capacitor while I was tearing a camera apart years ago. It was charged and you could hear like a static popping sound from it when I was tearing apart the camera. Now, this camera has had its batteries removed for quite a while, and I have my multimeter handy, so that way I can actually check it for voltage if I'd like. Anyways, we're going to go and open this up. The batteries have already been removed. The main batteries have. But I will go ahead and take out the clock battery. Okay, we're going to also take out the memory card as well. And we'll go ahead and start opening it up. You have two screws on the bottom that need to come out. Alright. Okay, so we got the back off. That's the back of it. Okay, the way this camera is assembled, both the front and back, when it's put together, it acts like a clamshell that covers the entire camera. So, the front should also pop off the camera like the back did. Try not to mess up our LCD display. Now we have ourselves a bit better view of inside this thing. I know it's not even on. I don't even have the video camera showing it right now, but this is the inside of the camera. That's what it looks like. And I'm still looking to see where our flash capacitor is at. It's the biggest fear I have of working inside of these kinds of cameras is a flash cap. Is it charged or is it discharged? You know, you never really know. That's just it. You don't really know. So here's our flash. Let's see. Set this on its back. See, right there's the flash. I know some of you guys who may work on cameras are probably laughing your tails off right now. You gotta understand, this is not something I do regularly. Okay, everybody, I've located the flash capacitor. It is right under here. Because right there is the flash driver circuitry. You can see a little bit of step-up transformer. I have my meter set to high voltage DC to the 500 volts level. I want you guys to see something here. Show you exactly why I have concerns. And why I don't suggest you just pop open your digital camera and start poking around inside with things. I want you to take a look at this meter. We have, if you look carefully, here and here are terminals. Now the black spot is actually, I think, the positive of the capacitor. But I can actually branch over and touch this next terminal and I get a connection. I want you guys to look at the voltage that's stored in this capacitor. Now I'm assuming this is probably a 300 something volt flash cap. I'm going to prop this meter up on something so you can see a little better. Look at that. See? You can see it going over 200 something volts. I'm going to touch this thing. So we have approximately 218 volts in that capacitor. Yeah, 214 volts, guys. That's nothing to play around with. The flash on the camera was last used about 2 days ago. However, it is not uncommon for cameras to top off the flash cap regularly, even though the flash is not being used. This is why this is so dangerous. This can be dangerous. You can see the longer I have my meter on this, the more this discharges. We're down to 209. So it's a high voltage, low capacitance capacitor. But it's still enough to give you a nice big jolt. It's enough to really hurt. Okay, everybody, after lots of time and patience, the flash capacitor has been successfully discharged. It involved using my multimeter. I set it to the same reading I just shown you. And the thing is, the capacitor, I don't know exactly what the microfarad rating of it is, but it's not a very high capacitance capacitor. It's just a high voltage, low capacitance capacitor. So the multimeter itself was able to drain it down, but it took forever. It took forever, about 25-30 minutes or so. I'll be sitting here and holding the terminals on there and watching this count down to basically zero. I could have possibly put a higher load on it. I've got some 50 ohm resistors, wire around resistors around here somewhere. I think they're like 4 watt 50 ohm resistors. I have no idea where they're at though. I could have potentially used those. The thing is, you may have seen online where, like for example, if you go search like a microwave or some other appliance that has one of those larger caps in there, they say you can discharge it by using your screwdriver to short out the terminals. It's not necessarily a good idea to short out terminals on a camera like this, because a capacitor isn't really, I mean, yeah, this flash does pull a good bit of juice, I do think, but it's not like a dead short. So they always suggest that you use an alternative means. The multimeter concept was found out online. Although I didn't actually have an analog multimeter like they suggested. I mean, this one here did the job just fine. I just sat there and even monitored it till it got down to about 0. Well, once I got down to about 12, I connected these computer fans up to it, and that just, like that, it was discharged. So it's safe to say our camera is now ready to be worked on. Now I can actually show you, well, get the flashlight and I'll show you what that flash cap looks like. The flash capacitor is right back there, and it looks like your typical motherboard or power supply capacitor, but like I mentioned, it's a extremely high voltage but low capacitance capacitor, and it's just tucked right away right under this PCB here. And what's funny, really funny to note about this is the same PCB that contains the flash driver circuit. It's the same circuit board that has the buttons for power and the shutter. So it's funny to think that let me get you a better focus here. This little button here for the power, it's just inches away from about 250 to 300 volts DC. It's just inches away. It's kind of creepy to know. But anyways, I don't know how this is going to go. Yeah, I really don't. This camera's been sitting in storage for years, and it'd be a shame to just toss it out without trying to fix it, you know. But at least now that our flash cap has been discharged, I feel much safer working on this. Now if we can figure out how to get the lens assembly out, that would be great. I think the flash is going to come out first, from what it looks like. Like I mentioned, there's not really much information online about disassembling this model of camera, so I'm just having to just figure things out in a way. Got this paper towel here and set this under here so that way I don't scratch the LCD all to pieces. I could take it off, but I mean, yeah, I'm thinking our flash is gonna have to come off of there. So let's figure this out here. Yeah, one screw and it lifts right out. There you have it. Actually, let's see. There's a couple of wires that feed to this. Actually, I think it's the wires that run the LED that's on the front of this. This Canon has an LED light on it that lights up when you go to press down the shutter button. When you don't fully press it in, but you press it halfway to make it focus or whatnot. It's the most handy thing on this camera if you're trying to macro focus in dark conditions. And that piece of crap traveler camera from Aldi doesn't have that, and it can't focus worth a crap when it's you're trying to focus on something dark. Okay, so I see what looks to be. Okay, I think our LCD is going to have to come off of there. Yeah, let's go and take the LCD off. Go and do it now. Now that I'm more confident working on this thing, now that I know there's not 300 volts DC just waiting there to bite me. I don't know exactly what the full charge of flash voltage is on this camera, but usually the flash caps are rated for around 300 volts or so. It's nothing to play around with. They say the amps are what actually kill, but depending, on these capacitors, I don't know exactly what the charge is, but the best case scenario is if you get hit by it, it'll just throw you across the room, or you'll have it'll just bite you. But worst case scenario is you could end up in a much worse situation from getting electrocuted. So this is definitely not my first time doing such a video or discussing that in a video, the dangers of a digital camera, because they don't necessarily tell you that on the camera itself. They don't tell you that there's high voltage inside. And I think that's kind of wrong. They should tell you that. At least warn people who unsuspectingly open up their digital camera trying to be Mr. Fix-It. Now, of course, I've this isn't my first rodeo with digital cameras. I'm already quite familiar with the inner workings of many of them, and I know the hazards. The biggest hazard being the flash cap. A lot of people don't know that. And this definitely wouldn't be a good situation to open up a camera, trying to work on it, and get bit by a flash capacitor, or possibly land in the hospital because of it. Okay, let's see how this comes out of here. Okay, this looks to just pull out. And these are sort of like the ribbon cables, like on a laptop, so to say. I think it's just a pull out design here. Oh, I see it. This little piece here lifts up. There we go. I don't know if I'm getting all this on video or not. And that just pulls right out. It's not a bad idea to shoot video, even if you're not intending to upload it to YouTube or whatnot. It's a good idea to shoot video when you're tearing something apart like this. That way you kind of have a good idea of how it goes back together. You're better off that way. So I'm curious to see if the shutter on this is jammed, or if it's just, or if I think it's just like a little electromagnet that actuates the shutter. I'm curious if it's if it's either the shutter itself is stuck, or if the electromagnet is just simply not getting power. Yeah, it's just trying to figure this out. So many itty bitty wires inside this camera. It's crazy. Try and get this board out again. The thing about it is I gotta be very careful not to accidentally mess any of these wires up. And they do have glue over the ends of the board. But you still have to be extremely careful. Yeah, this is crazy. I'm trying to be as gentle as possible with these wires, just trying to get them out from behind their little guides. Okay, everybody. Another day, and I decided to go ahead and try to finish this thing up. Well, kind of a change of plans. This Powershot A480 I actually get to keep. So there's no real need for the A470 anymore. So I figured I was going to tear it apart and show you guys the failed component. If I had to scrap the camera for parts, just for fun. Here's our failed part. It's the shutter. Right there. It's built into a lens assembly, and I believe also the aperture is in there as well. I mean, it's stuck open too. Not exactly sure why. I don't generally recommend sticking your screwdriver into any sort of lens assembly, but we have an electromagnet there and an electromagnet there. Let's see. I mean, it could have been a case of those not even getting power. You never know. You never really know in a situation. We'll go over the rest of the stuff out of the camera here shortly. Let's just go and take a look at that that aperture. As just mentioned, I don't have a real need for this camera anymore, so go ahead and just open it up. See what we have here. And I mean, in the process, I mean breaking it to get into it. Obviously, we don't care about it. We're just going to go and force ourselves right in. Hopefully I don't shatter the lens doing this. Okay. There's what's inside. And we should be able to slide this little piece back and forth. Yep. You see we just closed the shutter. So it looks like there perhaps may have been a power failure to the, there could have been a connection failure to this device. Because I can just operate it, click just, just like that, and it's working fine. See, it looks like an eye blinking. That's exactly what it is. It's like an eyelid for the camera. So we're going to go ahead and pull the rest of this off of here. And if required, we'll use brute force. Okay, so there you have it. That's what's inside there. Yeah, I was curious to see if that would fall out by chance. Looks like it doesn't want to. This is what's actually inside your camera lens. This guy right there. So inside the actual PCC move in and out, you have what looks to be a fisheye lens assembly, which isn't exactly what's in charge of the zooming, but it's actually a combination of the inner lens and an outer lens assembly that move back and forth together. So inside the camera you have this is the back of the lens assembly. I believe this part is in charge of your focusing. A stepper motor goes right there, and I think drives this lens here up and down to provide your macro focusing. Sort of like I just see here with this camera here. That moves in and out as needed to provide macro. There is the motor that operates the retractable lens assembly and zoom. That little guy right there. There you get a close look at it right there. Here is the main board. That's what that looks like. Here is a daughter board that houses the SD card slot and some buttons for operation of the camera, along with the dial. It just has little contacts in the back that rub against these contacts. There's the stepper motor I was telling you about previously. Here's part of the camera frame or chassis. This is where the batteries go installed. And what's hilarious about this is the dang battery compartment is still usable. I mean, look here. See, there you go. It can still be used if you want to use it for something. All I have to do is just chop the end of this plastic off, and that'd have me a little battery compartment for whatever I want to use it for. There's the front of the camera. rear of the camera, there's your contacts on the back of that dial. This is the CCD or Cmos sensor. 7.1 megapixel. Compared to the A480s, I think it's a 10 megapixel. Yep, 10 megapixel. Huge difference. Just in a slightly different model of camera. And here is the most dangerous part of the entire camera. I can't stress this enough, guys. If you go to open up a digital camera that has flash built in, you got to be careful. Got to be careful. This is your flash driver circuitry. And what's absolutely hilarious about this, the thing I mentioned already, is the terminals of your flash capacitor, which already is discharged, are less than 1 centimeter away from the power button and about 1 inch away from the shutter button. So if you have a Powershot A470, just know that when you press the power button to turn your camera, your finger is less than about 1 centimeter away from about 300 volts. There's the on this side, you can see a step-up transformer. All it does is again, the flash cap is discharged. Again, there's no spark at all when I bridge the terminals. But this is just a it's sort of like in a switching power supply. Your power comes in from AC, it's rectified to DC, and then it gets switched to a very high frequency AC. You would never think it, but the 2.4 to 3 volts that your battery is supplying, your two AAA batteries are supplying, AA batteries are supplying, are getting stepped up through this circuit to around 300 to 330 volts DC. It just steps it up through this transformer, through a driver, through a high frequency AC, comes out as a very, very high voltage that can kill you, and charges up this capacitor. And your camera could be sitting in a drawer, it's sitting in storage for months, perhaps years. That cap could still be easily charged and be willing to hurt you if you happen to touch its terminals. I kid you not, guys, that thing could be sitting for a long time and still be lethal, and still have a lethal charge in it. Low capacitance, only 80 microfarads, but 330 volts. That's what it's rated for. Now, I measured the voltage in this thing earlier, and it was like 240 volts about, or something like that, before I discharged it. And that was just sitting for a day. Now, perhaps the camera's flash may have been used a little bit, may have discharged the flash, and it didn't have a chance to fully recharge. But again, this is the most lethal device inside of a digital camera. If it has flash, you be warned. It's there waiting for you if you decide to open up your camera. You have to know how to safely discharge these things before you go in and mess around inside your digital camera. But yeah, that's the look inside of a Powershot A470. So from the way things are looking, I would not have been able to repair this thing, because it seems like, as I mentioned, the shutter, whatever I've done with it, was stuck closed for, I believe, other reasons. As I mentioned, I think the electromagnet that controls it was not getting power. And we can find out, perhaps. If it wasn't the electromagnet, it could have been something like, could have been wiring going to it, or something like that. You never know. You gotta think, the aperture and shutter inside the lens, every time you turn the camera on, it moves forward and back a little bit. When you zoom, it moves forward, it moves back. It moves all over the place. So after all all the years of excessive use from your camera, this thing's moving back and forth, back and forth, back and forth, back and forth. I mean, you can't rule out the possibility that that perhaps the connection going to this failed. I'm gonna check this for resistance and see if it's got continuity or not. And we might see some action from the aperture of the shutter when we do this. I can't get a definite reading. It's jumping all over the place due to probably not getting a good connection on the terminals, but the coil over here to the left is getting continuity. But the other one, let me try again. Now it seems to be reading something. So it could have been a connection issue between this guy and the main board. Now the aperture was working, but the shutter was not. You can see I can slide my finger and get it to work. See, it closes right up and opens, so it's not jammed. Yeah, everything on here seems to be fine. So anyways, that was a teardown of a Canon Powershot A470. I know this may have been a bit boring, I don't know. Anyways, hope you guys enjoyed it. Thanks for watching. Hey everybody, I sure hope you guys enjoyed this video from Q Computer Channel. Remember to like the video, subscribe to Q Computer Channel for more updates, and remember to tick the bell so you actually get notified of these updates. Did you know that I am also on a second channel that's Bike Geek MTDX? Over there you'll find videos of bicycling, weather, elevators, and all sorts of other neat and interesting stuff. Feel free to subscribe to that channel as well. And again, I thank you for your support, and thanks for watching this video.